Welcome back, everyone. We're gonna go over lesson 7, experimental design, which is and we're gonna go in depth with blocking by matched pairs. So this is the last lesson of this unit. Just a reminder that you do not have to do the Stroop effect activity. That is something that we will do in class once school starts. Okay. Let's go ahead and get started. Subjects who are similar in ways not under study may be matched and then compared with each other on the variables of interest. Matching, like blocking, reduces unwanted variation. Matching is similar to blocking, with blocks being of size 2. You can also use a matched pair design if the experimental unit or subject has the ability to receive both treatments, and you can compare the experimental unit or subject to itself. Okay. So the reason why we do match pair design is because sometimes, like, let's say if you're trying to find if there's a difference in the medication between males and females, you want to match them up based on like their age. So, for example, comparing the results of a male that is 21 to a female that is 21 will give you a much better result than comparing a male that is 30 versus a male that's 20. So when pairing two subjects, okay, this is what we want. We want pairs to be as similar as possible. Okay. And then within the pair, we're going to number the experimental unit as 1 and 2. Using a random number generator, assign assign 1 or 2 to treatment 1, other gets the treatment 2. And then you measure your response variable. Okay. When one subject, so this is its own pair, gets both treatment, you're going to number 1 and 2, random number generator to pick first treatment, and then second treatment later. Measure response variable. Okay, so we're going to go ahead and go to the next page and go over the model problem together. So, this first one says American Bicycles, located next to a large university, wants to test out a new tire that is supposed to wear better than current tires. They obtained a random sample of 100 bicycles from students who own them at the university. Design how American Bicycles can test their new tires on these 100 bicycles. So treatment 1 is going to be the new tires, and treatment 2 is the old. So design this experiment using a completely randomized design. So this means that we are going to number 1 to 100, right? Random number generator to select 50 for treatment 1, and other 50 gets treatment 2, and then record wear on tires. Okay. How could we improve our design in part A? How would this improvement be better indication of the true difference in wears of tires, new versus current? So the best way to do this is actually to do a match pair on its own. So basically what you're going to have is this bicycle, okay, that has front wheel and a back wheel, and you're going to choose whether which tire is going to, whether the new tire is going to go in the front or the back. So 1 is number front wheel as 1 and back as 2, using a random number generator to select 1 or 2, and this will give you, this will be where the new tire goes. And then 3, measure, wear, and compare differences for each bike. And the reason why we want to do a match pair test is that, you know, each bike will have a different weight, so it does wear on the tire differently. Each rider rides differently. How they brake also affects the wear on the tires, so that's the reason why we would do this. Model problem number 2 says that a new weight loss pill claims it can help people lose weight faster than exercise alone. All members of the study will exercise as normal, and you will have the following random selected sample for the experiment. So T1, so treatment 1 is the pill, and then treatment 2 is going to be the placebo. Okay. Propose a completely randomized design for this study to compare these two treatments. So 1 is number patients or participants 1 through 10, random number generator to choose 5 for treatment 1, others get treatment 2. 3 is we're going to measure weight loss. Okay. Propose a match pair design for this study to complete these two treatments. So in this case, what we want to do is we want to match by gender and age. So for example, the pairs here would be 1 and 6, which are males in their 20s, 2 and 10, which are females in their 40s, 3 and 7, and 4 and 9 are females in their 20s, and 5 and 8 are males in their 40s. Okay, then number each pair as 1 and 2, random number generator to choose who gets treatment 1, other gets treatment 2, and then measure the weight loss. Okay, and so that concludes unit 1 of our class. Again, you do not have to do the Stroop effect activity on the next page, so do not do this. We are going to do this in class together sometime between the first 2 weeks of school. If you have any questions, make sure that you leave a comment down below or send me an email or even put it onto the Google Classroom.